Hey, Red Devil Scholars, how you doing? It's Coach Scott, and our fourth video, our fourth lecture on ionic compounds, ionic bonding. And today we're going to be talking about how we can predict what a compound's formula is. Okay, and y'all will do great in this. So, how do we predict an ionic formula? Okay. So one, we've got to make sure that there's an electronegativity difference enough to where we say that it's ionic. If you recall, our border is 1.7 difference in electronegativity. So I've got potassium. It's got an electronegativity of 0.8. And then I'm going to see what it does with oxygen. It's got an electronegativity of 3.5. So if I subtract 3.5 from 0.8, I'm tired, so I'm just going to use my calculator. All right, 3.5 minus 8.8, that's going to give me 2.7. Now 2.7 is above 1.7, so this will form an ionic compound. So what's the formula? There's a couple ways we do this. One is this. How many additional valence electrons does oxygen need to have a full octet? Well, recall what the valence of oxygen is 6, so it's going to need 2 more valence electrons. Then we need to ask ourselves, how many valence electrons does potassium have? Of course, it has 1 valence electrons, it's group 1. So then we ask, how many potassium atoms will it take to give oxygen the electrons that it needs? All right. We always put the metal first, then we put the nonmetal. And if we see that there's going to need 2 potassium atoms of 1 electron each to make those electrons for oxygen. You can see that right there. Okay, that electron is going to go to oxygen. It's going to steal it. That electron is going to go to that oxygen in that spot. So now oxygen has a full octet. It's stolen 2 electrons, little thief, all right, from potassium. So you're going to have K2 or 2 potassiums, 1 oxygen. Okay. So let's play again. Okay. Well, we just solved all that one. So anyway, let's look at magnesium and nitrogen. Okay, nitrogen is a group 15, so that's a nonmetal. Magnesium is a metal, so that will form an ionic compound. So we need to ask ourselves, how many additional valence electrons does nitrogen need in order to be happy, have a noble gas configuration? Well, each nitrogen needs 3 valence electrons. Then we have to ask, how many valence electrons does magnesium have to offer? Well, it has 2 electrons to offer. So now we have to ask ourselves, okay, a nitrogen needs 3, magnesium has 2. So we need to find a common multiplier, right? So if I multiply nitrogen by 2, all right, and magnesium by 3 and those electrons, then it's going to give us 6 electrons. So the ratio would be magnesium 3, nitrogen 2, and that's what it is, a ratio. Okay. Now this is the method I prefer. I call it the crisscross method. All right. Because that way you don't have to use common multipliers and things like this. So what I do is I'm going to write those ions down side by side. Magnesium 2 plus. Always write the metal first. That's just what we do. Then nitrogen is next. It's got a 3 minus charge. So then we're going to crisscross. Do it again. Crisscross. Crisscross. We're going to go down. So that's a 3. So I take that 3 minus, put it down there. I can drop the minus now. I'll take that 2 plus and crisscross it down to the nitrogen. Now I'm going to have the lowest whole number ratio, magnesium 3, nitrogen 2. That would be magnesium nitride. Not hard, is it? All right, so let's look at calcium sulfide. We want to make sure we don't screw this up. All right, so what is our cation? What's the metal? Well, it's calcium. It's in group 2, so it's going to be Ca2+. What's our anion? Sulfur, right? It's in group 16, so it's going to have a charge of 2-. So now I've got Ca2+ and S2-. I do a crisscross applesauce, right? And I come up with Ca2S. Okay, now is that the lowest whole number ratio? No, it's not. Right, if I can divide everything in by 2, I come up with CAS, and that would be the lowest whole number ratio. Okay, so is the formula for barium sulfide Ba2S2? Well, that's not the lowest whole number ratio, it's BAS, so that would be false. So what's the formula for the ionic compound between magnesium and sulfur? Well, magnesium is +2, sulfur is -2. Crisscross, I'm going to come up with the magnesium sulfide MgS. The formula for the ionic compound between cesium in group 1 and oxygen, -2. Well, what I'm going to do there is CS +1, O2 -2, crisscross. 2 comes down to the cesium. I'm going to come up with C. All right. The ionic compound formed between calcium +2 and nitrogen -3. Let's see. Crisscross +2 -3. That would be calcium 3, nitrogen 2. That would be a C. All right, we're going down. What's the ionic compound formed between aluminum and oxygen? Well, aluminum is +3, oxygen is -2. Crisscross, Al2O3. That's how the numbers end up. Let's see, Al2O3, and it is Al2O3. What's the ionic compound formed between, calcium and aluminum? Calcium and aluminum. Give you a second on that. There is no ionic compound of calcium and aluminum. They're both metals. The electronegativity difference is too great. So that would be D. What's the ionic compound formed between P and Br? Phosphorus. I think that's in group 15. Bromine in group 17. Yeah, think about it. Well, that would be a C. This is not ionic. It does not have the electronegativity difference. What's the formula for sodium phosphide? Sodium phosphide. Well, phosphorus is in group 15, so it's going to have a -3 charge. Sodium, +1 charge. Flip them, crisscross them, whatever. In a 3P, that would be a C. One more, I think. What is the formula for strontium bromide? Strontium, +1, it's in group 1. Bromine is in 17. So, of course, that is going to be, strontium is in group 2. Sodium is in group 2. So it's going to have a +2 charge. Bromide is in group 17. It's going to have a -1 charge. Crisscross them, SrBr2. Okay, so that's a simple naming of what we call a binary ionic compound. It's called binary because there's 2, like a bicycle, 2-wheeled. Okay, and we'll get into more of this. We've got about 2 more lectures and a lot of work. So we've got a good another week to do on this. All right, guys, this is Coach Scott saying, guys, have a good, safe night, and I will catch you guys on the flip side. See you guys, you outstanding Red Devil scholars.